Leah Holou. I am so pleased to moderate this special session. One of my important roles right now is to speak a little bit while people come in and get settled and get their coffee and finish saying hello. Each year at this symposium, we indulge in a half-day session focusing on one topic from many perspectives. And we invite influential and prolific scholars and practitioners to educate, illuminate, and stimulate us to think more broadly and more deeply on this topic. This year, the topic is voice and emotion. And I cannot take any personal credit for the construction of this session. I'm standing in this morning for Dr. Nancy Solomon, who sends her regrets that she couldn't be here to join us for the session. Nancy selected the theme and curated our list of speakers, and it's entirely thanks to her that you all are in for this treat. She titled the moderator's intro, Emotional Expression, as a vocal performer, and now she's a more practiced and better trained singer than I am. Most of my singing these days is in lullabies and private room karaoke and road warrior belting. But as a lifelong vocal performer, one way or another, what I've become attuned to is that voice offers not just a barometer or an instrument for revealing or concealing emotion or some mix of revealing and concealing at the same time, but it's also a proving ground for exploring your emotion, for interrogating what really lies there, what really lies beneath, what I'm really feeling, and for releasing stuck emotion and getting it up and out. And voice and emotion, not just individually, but certainly in combination, constitute some of the dark matter of other fields like psychology and neuroscience. Voice is not only the great revealer of who we are, it's also the concealer if we want. And it's not simple, like I flip a switch and now I'm moving from revealing mode to concealing mode and back again. It's an intricate, nuanced, dynamics mix of these things. It's an interplay. But we all know this, of course. I'm not telling you anything new, although I'm sure that our speakers this morning will tell you something new. They have a wealth of knowledge on this topic. One final note is that I was thinking about kind of how to set up this talk, and voice and emotion is, for me, a very special topic, something my brain loves to think about. And we live in a time when our fellow humans are in a race to create synthetic voices that mimic and even supplant the real deal. And this is all happening hand in glove with efforts not just to understand the workings of the brain, but to reduplicate the human brain. It's a really interesting time to be alive. And I want to make a call to everyone here, an appeal to really tune in and get forensic about observing vocal emotional expression in yourself and in the world around you and others around you. This is at once an age-old topic and a very timely topic, and we're in privileged positions as clinicians, providers, educators, and performers to actually observe and know these phenomena far more deeply than the average citizen does. Certainly far more deeply than the average AI coder does. And so there are very few people in the population at large who get voice and emotion at the level of understanding that exists in this room today. And each of us might have some opportunity to translate and contextualize some of the phenomenology of voice and emotion as we race toward this effort to figure out how to have the machines do this as well. So with that, I want to introduce our first speaker in the lineup, Dr. Sophie Scott. Dr. Scott is a British cognitive neuroscientist at University College London. Her research investigates the cognitive neuroscience of voices, speech, and laughter, particularly speech perception, speech production, vocal emotion, and human communication. I've had the pleasure of hearing Dr. Scott talk a couple of times, and I know we're in for a treat with her talk, which is titled Voice and Emotion, a Neuroscientist Perspective. Let's give her a round of applause.
Thank you for that really kind introduction, and thank you very very much for this invitation. It's an absolute joy to get to visit Philadelphia. It's my first time here, and when I was a child, the first music I really enjoyed was Philadelphia Soul. So I was like, this. I'm expecting to see like the OJs dancing on the top of a skyscraper or something. I won't leave till I see this. So I'm going to approach the voice by thinking about brains, because to a woman with a hammer, everything looks like a nail. I'm a brain person, but that's the direction I'm going in. I've started very well with my own first slide not going forward. Here we go. Obviously, voices are unbelievably rich sources of information. So if you hear somebody talking and you share their language, then you're going to be able to understand what they say. Your brain will be trying to extract meaning from this. But there's also all this other information. Some of it we are putting in communicatively, deliberately, intentionally, some of which is arising because of the instrument with which we are making the voice, and others are coming from interactions. So our age, our sex, our gender, that's all information in the voice. Our health is in the voice. Our mood, and obviously I'll be focusing on this, is intrinsic to the voice. Our geographical origins, our socioeconomic status, our affiliations, our identity, our affection. Because the voice also, because it's something we do, we change our voice depending on who we're with. Like I'm speaking differently to you now because I'm trying to be a very sort of, important scientist from the UK. And that's different. If I was in London buying fruit on Chapel Market, I'd be like, what's it, governor? Give us a banana. And it would all be very different. Because I'm to be trying to fit in with the man selling the fruit. It's a bit scary. So the thing that, if you think about the world of emotions rather than voice, it's completely a field dominated, in terms of expression and how we recognise emotions, it's dominated by faces. And I would argue that's because it's easy studying faces. But also, I think frequently people in that field forget that voices are a thing that we do. If I don't make any sounds, you won't know anything about my voice. It's an action. So if we just start by thinking about the neural systems that control those actions, we have basically, for humans, two different vocalization networks. The first one is specific to humans, and it's associated with the voluntary control of the voice. So this is just a snapshot of what's happening when somebody's talking in the scanner. And we get the classic kind of brain systems associated with producing speech. So in addition to auditory cortex activation, running down here, we get activation in sensory motor cortex, because you're feeling the articulations as you're producing those sounds. We get the supplementary motor cortex, we get the cerebellum, we have a little array of brainstem and subcortical structures, all involved in this complex production of voluntary use of the voice. So when you see somebody talking inside the scanner and we get these lovely images of the vocal tract in action, the sheer complexity of the productions that humans can make with our voices, it's reflecting basically a completely different pattern of volitional control we have over the voice. Other animals, arguably, there's some issues around some of our closer relatives, but in general, mammals do not have this kind of fine control. Even if they had the right looking vocal tract, they could not make the sounds that we make. What mammals use when they vocalize is another pathway that we still have that runs midline, down from the anterior cingulate, down through the periaqueductal gray into brainstem nuclei that are then driving the same articulators. And this is associated with non-verbal emotional vocalizations. So when we had a mouse somewhere in our flat a few years ago, probably more than one mouse, all right. I was in the flat on my own, and I thought it ran over my foot, and I screamed completely involuntarily, and the sound was just coming from, where's this coming from? And I just went on, and I had time to think, I don't know why I'm screaming. I'm not afraid of mice. There's no one here, but that's involuntary emotional vocalizations are more like animal calls than they are like speech, and I'll show you exactly what I mean in a second. But also that is, they are being produced by the same network. So when other mammals vocalize, they are using this network, apart from perhaps some primates, and that's why vocalizations in other mammals, they're reactive, they're emotional, they're not being produced under the same kind of volitional control, and they're simpler. They mostly rely on breath control and sort of stuff happening at the larynx, and they frequently reflect physiological changes associated with the emotion that you're going through, sort of the state that your body's in, although of course that's always true for the voice. And as I say, can frequently be involuntary. So this is somebody laughing in the scanner. This is an involuntary emotional vocalization. We've made her laugh. And you can see all of that fine control's gone away. The tongue's just sitting at the bottom of the mouth. The mouth is opening. And there's a lot of shaking going on because a lot of stuff's happening down at the rib cage. But there's no fine control, there's no fine movement. You have a very, very simple sound being produced here. And it literally is more like an animal call. So we just zoom in on the breath for a minute, and I'm sure you're all very familiar with these sorts of images. If we look at measurements from a breath belt, so just looking at what's happening at somebody's chest wall when they are doing different things, this is what you're all doing right now. It's called metabolic breathing. It's keeping you alive, don't stop. And you get this lovely sort of sinusoidal movement as the chest wall is expanding and contracting, as you move contract and relax the intercostal muscles. And when we speak, we use those same muscles completely differently. So if I take a breath in, and then talk, you see a totally different pattern of movement of the intercostal muscles, because what I'm doing now is I'm using those same intercostal muscles via that volitional system to maintain a constant subglottal pressure. And if I keep talking without taking another breath, you can hear that my intercostal muscles start to have to work really, really hard to squeeze the sound out. And one of these days, I'm either going to faint or urinate at the end of that, but I think we're okay. You're probably thinking, that was interesting but weird, Sophie. We can only talk or sing or beatbox or anything because of this fine motor control of the intercostal muscles, which is possible because we don't walk on our forelimbs, we walk upright. It's freed up our intercostal muscles. We don't have to use them to support our weight. And this lets us have produce speech over these longer or song, over these longer cycles of breath. If you couldn't breathe like this, even if you could speak, even if you had voluntary control of the articulators, you would speak on each breath. You get my point. So it's giving you that kind of, you can predict how long somebody's going to speak for by the size of the breath they take at the start of an articulation. So it's like that is the kind of cycle for the planning of speech, and also that pattern of breath control is where pitch control and rhythm control in the voice is coming from. It doesn't come from up here, it's coming from down at the rib cage. So very important for talking and for singing. And as soon as you start laughing, you see a very distinctive pattern. This is not all emotions working this way, but they are. Laughter is an extreme example. You start getting these very, very big deflections, very, very large contractions happening very quickly. And each one of those exhalations is just pushing air out of you, and that's giving you the ha sounds, and that's giving you the kind of the amplitude envelope shape of laughter, which is very highly recognised. And if there's a competition between this involuntary laughter and the voluntary use of breath for talking, or sort of fairly automatically controlled breath for staying alive, the laughter or the involuntary vocalization will win. It has a different kind of access to motor control, and it can really overwhelm people. So if we look at what happens when somebody starts to laugh and think about what's happening to her voice, this is somebody talking on the radio on the BBC's flagship news programme, the Today programme, where people are not supposed to laugh. And she hears something that makes her laugh. And the thing to really spot, listen out for, is that what starts to happen is she's losing control of that ability to speak with that voluntary network. The involuntary stuff's creeping in. The first thing to go is that very fine control of pitch that's happening because of how she's the intercostal muscles are supporting breath control for normal speech production. So the first thing you'll hear is pitch starts to go wrong. Pitch is shown down here at the bottom in blue.
Sinrock's unpopular replacement has now been dismissed, with the Army's popular Chief of Staff, Jack Twatt, taking over.
A 40-foot sperm whale, which was stranded in the Firth of Forth for more than 4 days, is now thought to be swimming towards open waters again. It freed itself late last night. Marine experts are hoping to establish this morning whether the whale is finally back at sea.
Right, whale. 8:10 is the time of investigation.
So if you love voices, this kind of thing's just catnip. I love it. The man coming down the line at the start, he's not in the studio, he's on the phone, and he's got to say a rude word. I don't know how it works in the US, but in the UK, twat is a rude word, and you would not just say say it on the radio. And he absolutely goes for it, nothing to see here, popular chief of staff, Jack Twat. And back in the studio, if you listen really, really carefully, this is before Charlotte Green starts talking, there's a little pause, and in that pause, somebody says 2 words to her, and what they say is, Jack Twat. Because they are trying to make her laugh. And at first, she's okay, the whale in the Firth of Forth is doing it, and then it's very distinctive, loss of control of the pitch of her voice. If you didn't know she was laughing, if you perhaps were not a native English speaker, when it can be harder to hear these things, it may have also sounded like she was starting to cry, where something very similar is going on. But it's all to do with that, you're losing that voluntary control of the intercostal muscles. And then the pitch of her voice shoots right up, and by the end she's making squeaking noises after she's stopped talking, because now she's fully laughing. And she'll get in trouble for this. This BBC does not like it happening, but that's how powerful these involuntary effects can be. So you're literally hearing 2 different motor networks duking it out, and one of them winning, and you're hearing that through the voice. It's also important to think about just how those sorts of, what we mean when we're talking about emotion in the voice, because sometimes what we mean is somebody speaking in an emotional way, and I don't mean you, I mean in the kind of neuroscience field, and sometimes they mean these non-verbal emotional vocalizations, and they're not necessarily the same, or they have some similarities. So this is a study where we took speech which was being said in different emotional ways, and we had different talkers, and we had different emotions, and we had different numbers. Everyone's saying numbers. And this is using a technique called noise vocoding, when you're basically stripping all the content out of a sound and replacing it with amplitude modulations that, as you add in more channels, give you something that sounds more and more like a kind of whispered speech. What you're not doing is replacing the kind of source information. It's kind of, if you think about it, you're adding in more and more about that filter information, what the upper vocal, the articulators are doing. It always sounds noisy. You never hear something that sounds like a human voice. And then we look to see what's the difference between the cues that get you to intelligibility and the cues that get you to emotion in these voices. So if we just click through, this is one channel, you won't be able to understand anything. This is just the amplitude envelope. And you can see there for the spectrogram, there's just no spectral detail whatsoever. If we're now in 6 channels, this is like somebody with a cochlear implant would hear something like this. You can see there's more spectral detail, and you should start to understand some of this. 151, 143. Now, you probably, even if you could get some of the speech out of that, what you probably couldn't hear was any of the emotion. It's saying things like 141. And what we find is, as you add in more and more channels, you're literally giving more spectral detail. Intelligibility for speech increases in a way that completely tracks the amount of spectral information. Speech perception is really dependent on spectrotemporal detail. As you add that in, people understand more. That people never get good at spotting the emotion, because you never get the pitch back, you never get the voice quality back, all that kind of information that is being added in, well, is always there in an emotional voice. It's not being replicated with these noisy stimuli, and you need more. So intelligibility in this context is relatively easy. Emotion is just not being conveyed. And you get something very similar if you do the same thing with non-verbal emotional vocalizations. I apologise for this graph. What we have in blue is showing the recognition. Here we've got triumph sounds, achievement, laughter sounds, amusement, anger, contentment, disgust, fear, pleasure, relief, sadness and surprise. And the lines in blue are how people are spotting the unmodified speech, so emotional sounds. So they are best when you just have the original sounds. When you go down to the 1 channel and the 6 channel examples, it really drops away for almost all of the emotions, with the exception actually of laughter. Laughter, because you never lose that amplitude envelope that's just reflecting that ha 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 sound. That is always well recognised. And we also have another condition here which is shown in green, and that is rotated sound. So you take the sound and you literally flip it in the spectral domain, and that destroys intelligibility to a large extent, but it maintains pitch profile. and that is helping people. They are a little bit better when you've got, for some emotions a lot better, when you've got that pitch profile. So that's not true for spoken language. You destroy intelligibility. For emotion, you get a little bit of pitch in there, that still helps you. And you can see that when you aggregate across all the emotions. There's also the case that for people's recognition of different emotions, if we look at emotional speech and non-verbal emotional vocalizations, they are not the same in terms of recognition. On the whole, and that's the line shown in green, people are much better at recognizing the emotions that are being expressed in the non-verbal emotional vocalizations. Recognition overall with speech is less good. That might be because they're post-stimuli, they've been acted by somebody. It could also be because there's just so much more going on in speech. If somebody is talking, they've got multiple intentional use of the voice going on. They are trying to get the words out. So the way that interacts with emotion may simply mean that the emotion expression is less, it may be more ambiguous. That being said, there were some emotions that were very well produced and recognised from spoken language. Amusement, so people putting in laughter sounds basically, people pick up on that. Anger is very well expressed in a voice. If anything, it's better expressed. In fact, we did a cross-cultural study where we were looking at these phenomena with members of the Himba community, and if you ask the Himba to produce emotional vocalizations, they can do that for all the scenarios you give them, but if you ask them to produce emotional vocalization that goes along with being angry, they start shouting at you. Like, for anger, people want to talk, and I think actually that's probably what swear words are. I think their origin is in a kind of aggressive use of the voice, coming completely through speech. It's not bad for fear, although fear is somewhat reduced anyway, but it's really bad for pleasure, it's really bad for relief, and it's coming out as being better for sadness. Though I think that might be because our sad stimuli here aren't particularly good. I'm happy to take questions on that. So there's definitely, they're not mirror images of each other. Emotional speech and non-verbal emotional vocalizations, they're not just one's got more speech in there, they are doing somewhat different things. When we think about emotion and the brain and the voice, we also need to think about that emotion doesn't exist in the human mind and brain without it also existing in our bodies. And of course, voices are actions that we make with our bodies, and things that affect our bodies will affect what our voice sounds like. The first time I did stand-up comedy, I was terrified before, and I was absolutely terrified. And then afterwards, there was quite a lot of laughter, and I was like, brilliant, and I knew there was a recording, so I thought, I'm going to go and listen to that recording. And when I listened to the recording, all I could hear was an absolutely terrified woman, because I was very, very frightened. I wasn't intending to sound like that, that was not what I was going for, but that absolute rush of adrenaline, it's the fight or flight response, and it affects the vocal folds. You get distinct kind of high-pitched, wobbly qualities of the voice that actually is very hard to fake. So, what we need to think about when we think about emotions and brains and voices is that, as I say, emotions aren't sort of abstract concepts in the brain. We kind of map emotions out in our brains. And the way that we do that seems to be a lot to do with how our brain is representing our body. So there's a very important bit of cortex which sits behind the central sulcus. That's primary motor cortex there, and that's somatosensory cortex. And somatosensory cortex is getting information about your entire body. And it's representing it in a way that actually maps out the body from, so let's look at the side of the brain. If we think about going from the bottom here up to the top, and then imagine we're looking from the side. So down here, so to orient you, that's down here, we've got all the articulator stuff. The lips, the eyes, the tongue, that's all down here. So as we move up, we then get to hands, and then we get to body, and then kind of going up and over the top, and so disappearing into the sulcus down there, we get legs and toes and genitals tucked away. Next to the toes. The other thing that you'll notice here is that the size of this bit of the somatosensory cortex that's associated with each bit of the, got information, sensory information from every bit of the body. It's not tracking the size of that bit of the body, so the back is very large, but in fact it's represented in a very, very small way up here. It's tracking how sensitive those bits of the body are. So your lips are really sensitive, your hands are really sensitive, your tongue is really sensitive, and they look huge on this sort of brain's eye view of the body. Motor cortex, which is sitting just in front of that has something similar, a similar map, but now that's associated with how much fine control. And in fact, if you make a model of a human that is scaled from this brain's eye view, that's the sensory homunculus and that's the motor homunculus, so it's very, very distorted perception. What does he mean for your voice though? Well, if we look at the brain systems, this is that kind of network I was showing you before, the brain areas that are important for controlling speaking, voluntary use of the voice. You do see some of that, you can see that somatosensory cortex, and it's lower down because when you're talking, it's primarily, something that you're using your lips and your jaw and your tongue, your facial areas for. We had an opportunity to work with an actor, this is Julian Ryan-Tutt, and it was a project, this is just one person, it was a project that the Wellcome Trust were interested in doing with him, and he wanted to know what happens when I'm acting. So he was in the scanner and he was saying this poem by John Donne, and he either just recited it in a very neutral way, or he performed it. So apologies for the recording, it's coming from inside the scanner.
Turn now goes that way, let me turn this.
So very flat, and then he's performing it.
Any so cheap a death as saying, go!
Now that's him talking, that's him performing, and you can see there's a lot more activation, and when you directly compare them, the difference between just reciting or performing is all in sensory motor cortex, all of it associated with the body. So when I asked him about this, we were just talking about what this could mean, he said, well, I'm trying to feel it. So he's accessing different voices by accessing that emotional state, and that's something totally, from a brain's eye perspective, associated with body areas, not classic emotion areas, but it does. There's a scientist in the US, Anthony Damasio, who's been arguing this for years, that your brain kind of uses an image of the body to map out emotional states. And actually, you can track what these are. So this is really lovely work from Lauri Nimenmaa in Finland, where he gets people just to colour in maps of the body to be consistent with where they think they feel emotions. And you get very consistent results across people. So this is anger up here, and people are feeling anger in the face, sort of in the middle of the chest, and in the hands. Anger wants to do stuff. Whereas fear is just here, and in fact there's a lot of deactivation everywhere else. Disgust is in the mouth and kind of right down in the stomach, guts. Happiness is bursting out of the head and all over the heart and coming down the arms and basically lighting up everything. Just draw a comparison between happiness and love. Little difference down. Back down near the toes. Sadness is almost like an absence. Surprise is the eyebrows. Neutral, kind of nothing. Anxiety, looking a lot like fear. Depression, another absence. Contempt, that's all up in the face. Pride, the head, the heart, and the sort of shoulders. Shame, the cheeks. Envy. So the important thing here is basically what people are colouring in. That is presumably how their brain is mapping out that experience in that sort of representation of body state. And I want to go on to the last sort of thing now about actually our connections to our own voices. So how we experience emotion as it relates to our own voice and the voices of others. Identity in the voice, which I mentioned up at the top, because voices are a thing that we do. And for a long time, I thought, well, that thing that we're doing with voices is speech. We talk, that's why we have voices. I mean, obviously I'm wrong in this, but that's what I thought for years. So I thought the brain networks that we had when somebody was talking was all associated with the linguistic elements of this. And identity kind of came out because your physical elements were constraining those, and that's because I didn't think about how complex voices are, I didn't think about how flexible voices are, how much we change our voices all the time, not just through things like due to emotion, but due to kind of, you will change your voice the more you like the person you're talking to, the more you will raise the pitch of your voice to join theirs. And you will talk in a way that is kind of reflecting your affiliation. So when I've been on the phone to my mum, I talk like her for about half an hour afterwards, and I love my mum, don't really want to talk like her. But that's, I'm expressing our relationship by taking my voice over to hers. And there's data on this. So, for example, boys talk with lower pitched voices than girls, although there aren't anatomical differences. It seems to be because they're reflecting the voices of the adult males that they hear around them. Women in the West, over the past few decades, have started to speak with lower pitched voices than they did, say, 40 years ago. And it seems to have actually tracked women going into the workplace. There's lots of stuff we can't change about ourselves, but we can take our voices down to not terrify the men so much. If you go to parts of the world where women are not as integrated into public life, what you'll find is, so for example in Japan, men speak with significantly lower pitches than they do in the West, and women speak with higher pitches than they do in the West. And when men and women are around, they exaggerate the differences even more. So they're really kind of, it's not just a basic sex difference there, it's a really big gender difference that they're marking. People will typically say they don't like their own voice if they hear it on a recording, and there's many different reasons why that happens. But if you trick people by getting them to rate how much they like voices, and you include their voice in there, and they must not realise it's their voice, they will rate it as highly, because you're talking with the voice you want people to hear. And if you take out the uncomfortable things about what that doesn't sound like what I was expecting, you will be talking with the voice that you'd like other people to hear, so you're likely to like that voice. And of course, as I said, we'll change our voice a great deal depending on who we're talking to. So identity, arguably, is performed as the speech production is it's reflecting all these, our aspirations. So I'm not expecting anybody to recognise this. This is from a radio programme in the 1950s in the UK called Hancock's Half Hour. It's basically the first real sort of sitcom. It was almost exactly the same kind of setup as Seinfeld, 40 years later. And the reason why it was significant was my father, the guy in the middle doing this, he's Tony Hancock, he's the star. And my father adored him, he adored Tony Hancock. And when my father died a few years ago, I started listening a lot to Tony Hancock's radio shows, which you can still get, and they are still very funny. They're good, they're well written, well performed. But the thing I couldn't get past was I kept hearing my father, because my father loved Tony Hancock and talked like him all the time. And because he died in the 60s and his programmes weren't on TV and the radio programmes weren't on that often, I hadn't really been exposed to his actual voice. So a lot of my father would have been a young man, and this was someone who was famous, and he kind of loved him and wanted to be like him, so he talked like him all the time. And we're all doing this. Interestingly, we did a study where we took people who are not professional impressionists, just people who are happy to have a go at changing their voice, and we put them in a brain scanner and we got them to talk with different vocal identities. Try your hardest, and we let them choose. You could say, I'll have a go at the Queen, Margaret Thatcher. What you get is bilateral and inferior frontal gyrus. Now, inferior frontal gyrus on the left is really strongly associated with speech production. And it certainly looks like when you are trying to change your voice, you are using the same brain areas you would use to control speech. You are driving that network harder. We also get brain areas on the right that are associated with vocal identity. But it was really, really striking that people are not using a different bit of the brain to try and control identity. They're using that same system that's very, very important for speaking in the first place. Interestingly, they show the same region on the right. And when people do things with their voice that aren't speech, and they do things like singing, you tend to see right as well as left, or right dominant responses. So we're seeing a kind of mix of maybe speech and song production systems being recruited to change the voice, and people who don't do this for a living. If we look at people who do it for a living, we see something completely different, and I'd be happy to take questions on this, but basically the vocal impressionists, they activate brain areas to do with actually body representation and sort of transformations of visual information. So the professional impressionists seem to think about what people look like and how they're moving to get to the voice, whereas the non-professionals are thinking about, how do I talk? And it is interesting, so going back to this point about sort of voice and identity and emotional connection, if you've ever worked with somebody with aphasia, so a classically associated, a speech production problem, a production aphasia, you might have heard it called Broca's aphasia, it's associated with lesions down here of classic Broca's area, that inferior frontal gyrus. This is just showing a composite image of a whole group of people who've had strokes like this. They've all had severe production problems and they've all recovered some ability to talk. People will typically get back at least single words. I've met people who are also very, very fluent. But what they all say is that it's incredibly difficult to have your voice taken away from you in a way nobody anticipated before the stroke. There's a very moving quote from one patient who said it's like identity theft. I can't be myself. I worked with people who've had foreign accent syndrome, which is like a tiny, tiny version of this, where people can still speak fluently, but their accent sounds like that of a foreigner to their fellow countrymen. Of course, it's not, it's a dysarthria, but we're always trying to label other people's accents. And this woman would carry around a cassette recording of her when she'd called into a radio programme years before on a local radio show, and she'd take part in a competition, and she'd make you listen to that first and say, now that's what I should sound like. That's me. So that kind of, even that identity information and the way that people make assumptions about you on the basis of that. So one of the things that drove her mad, she lived in a very small town in the middle of the UK, and people kept trying to help her how to get on the bus and things like that, and I'm from here, I'm not a stranger, I'm part of you. So this identity and emotion are really tightly interleaved here. And I just want to give you one last example of this. So we have to think about contagion. Contagion, behavioural contagion, catching behaviours of other people is very common in social animals. So a lot of the yawning you produce is happening just because you've seen somebody else yawn. And you're much more likely to catch a yawn from someone you know than someone you don't. Also, it's something we learn to do. Babies don't show any behaviourally contagious phenomena. Yawning, blinking, coughing, laughing, these are all behaviourally contagious for humans, and you're much more likely to catch them from someone you don't know and someone you don't know. You can actually see it when people are listening to different emotional vocalisations. So here we've got people listening to laughter sounds and sounds of fear and disgust. And for the laughter, you get really strong activation in brain areas that you would actually use to produce those sounds. If you think back to the stuff I was showing you at the start. So you're getting what's called orofacial priming, orofacial mirror activation, activated both by hearing something and producing it yourself. And it's much stronger for the laughter, so it looks like you're being primed to join in when you hear somebody laugh, even if you're having your brain scanned, which is monumentally unamusing. And very, very powerful. So I'm just going to show you, I'm sorry, it's all the examples are from laughter, but most of my work's there at the moment. So I've got a clip here of two men. The man on the right, he's going to hear something that makes him laugh. In fact, from the beginning of the clip, he is trying not to laugh. This man is worried about the situation, and he's trying to manage the situation, but he also keeps laughing and smiling every time his colleague starts laughing again, because that's just the contagion at play.
We're really trying to get out
there. He's already trying not to laugh, look at his face.
But so we can thank you. I'm going to thank you.
Okay.
I cried in the midnight hour, yeah. You heard my cry. You followed all of my tears.
Worried.
That's my power.
Where did that smile come from?
Really
worried, look coming up.
Oh, yeah.
Why so worried?
I was actually. I certainly did enjoy that. He's going out in the spirit. He's getting the Holy Ghost over here. We want to. He ain't the spirit. He still loves you. We want to get and we want to give you a T-shirt here. Send them a T-shirt. Right here. Right. More conscious. Enjoy that, Danny. Florida. I love this singing. It brought me up.
I always think I can stop that clip sooner than I can, and I've got to get to the end. So basically, there were different kinds of laughs happening there. One was absolutely spontaneous, that was an involuntary vocalisation. You can see him trying to stop it from happening. And then his colleague is just joining in, mirroring that behaviour back, while also trying to manage the situation. This is obviously inappropriate. We should not be laughing in the face of someone who's called in to sing a sort of meaningful song. And one of the things we know about contagion is that it's modulated by familiarity. And particularly with laughter, people have shown you're much more likely to catch a laugh from someone you know than from a stranger. But we wanted to know what would happen if we kind of had gradings of familiarity. So we had, I'd actually collected a load of laughs from people I know. And I thought, well, we can look at this, they know each other to different or lesser degrees. Why don't we just ask them to rate how contagious the laughter is and also how familiar the laughter is, and look to see how they correlate. So this is the network, and you can see some people very closely connected. So that's me and my brother, very closely connected, and then that's a group of sort of people from, I think they're all comedians, and these are a colleague that knows me, doesn't know anybody else. These are colleagues from UCL. So you've got the little subgroupings within this. And different, the strength of the line varies, so stronger and weaker connections. And we get very strong effects of familiarity. So the line in grey is showing how people rate contagion with a sense of social connection when they don't know the identities of the people that they're hearing laugh. We haven't told them who the people are. And then we run the whole thing again, and this time we tell them the names of the people. So now you get the exaggerated effect of familiarity, because now people know for sure this is somebody I know. But we also have in there, of course, people hearing their own laughter and rating that. And what we find is everybody rates their own laughter as more contagious than the laughter of other people. And that is whether or not they recognise themselves. Most people aren't peculiar people like me who hear their own laughter a lot. So most people didn't recognise themselves the first time. And it doesn't make any difference. That's really interesting. Why would you be the person who has the most contagious laugh? Is that because there's something about how we learn to laugh, and you're learning to laugh in a way that maybe mirrors the laughter around you? My partner had a father, his father had it was great. You could push him over into proper, when people lose it in laughter so much, they're just sort of wheezing and start choking, shaking with it. And Tom definitely laughs like that. Now, maybe that's genetic, but maybe there's an element of him having learned to do this. Is it because part of what happens with laughter, when we think about it, that sort of the duration of involuntary laughter is maybe if you had the experience that you were laughing and you were somewhere where you shouldn't have been laughing but you could not stop doing it, you are being contagious perhaps to yourself. Or maybe you're simply the person you are most familiar with is you. But we need to know more about this. But I think that's really pointing to this very strong emotional connection that you have with you, the sounds you make. And I just want to finish by kind of zooming out a bit, because I'm starting to think, my background is really, I've always been a speech person and a sound person, and I now think that, although I probably consider myself fully to be a voice person now, voice is a sound, it's a sound we make, and I think you can make a very good argument that sound is our social sense for humans. Our perception of sound co-evolved with our voices. It's critical for the development of vocal communication. Even moderate hearing loss will have profound influences on the ability to acquire spoken language. There's, in adulthood, the single biggest preventable cause or risk factor for dementia is uncorrected hearing loss in adults who've grown up speaking. And it's because you lose access to hearing, it's difficult to understand people when you go to the pub or you go out to a party, and you withdraw from social situations as a result, and that is really bad for your brain. And it's also the case that even in a world where we can be having all of our interactions via a screen, people are still having conversations as the primary source of social interactions. And that really matters. Those social networks matter. We know that you can predict someone's physical health, mental health, and longevity with the size and the strength of their social networks. It's not because that's a sort of an abstract thing that supports you by having, I have a sense of well-being because I know I have a lot of friends. It's because those are the people that you talk to, and those are the people that you laugh with, and you sing with, and you dance with, and you eat with. All activities which are highly mediated by you being able to make sounds together. Friends can also help you through direct mediums, but also, friends can help you when you need a friend. but also all of these activities not only are enjoyable activities, but they are associated with increased endorphin uptake. Singing, dancing, eating, drinking alcohol, making music together, these are all things that are positive in terms of endorphins, and human bonding is based on endorphins. And of course, that can also directly influence your health. Endorphins interact with the immune system. So I think that voices are basically always social and always emotional. Over the years, I've done lots of studies in the field of emotion where we've tried to come up with a baseline sound that we can use that's vocal and which contains no emotional information, and you cannot do it. As soon as there is a sound happening that's been made by a human vocal tract, people will perceive something emotional in it. There is no neutral voice. You can't, and arguably that's true for the face as well. What scientists call a neutral face, what they mean is there's no sort of movement with the facial muscles. That looks like a bitchy resting face, it's not nice. But it seems even stronger for voices. There really is nothing that can be neutral about a voice, because as soon as you hear that voice, you're hearing an identity, you're hearing emotion, you're hearing associations with other voices you know, and on, all the other information that's in there. So they're always social and they're always emotional because they are so important to these social and emotional networks. And I'd like to just thank my collaborators. Thank you.
Dr. Scott, wasn't that so fun? So fun. Excuse me. Next up, we have Dr. Miriam van Mersbergen, who is an assistant professor at the University of Memphis in the Department of Communication Science and Disorders, associate professor, pardon me. Dr. van Mersbergen has a performance background and directs the Voice, Emotion, and Cognition Lab, where she studies using a very multidimensional approach emotional experience and cognitive factors and how they influence communication and especially vocalization. So please welcome Miriam van Mersbergen.
Thank you very much to the planning committee for this opportunity to speak to you, particularly Nancy Solomon. And I am really humbled and excited to be part of this very august panel, speaking on something very near and dear to my heart. So I have no disclosures besides the fact that I get paid to do research for now. So when you do a public speech, a lot of recommendations are to come up with a joke or something interesting or a quote. And when I was writing this, I was not feeling particularly funny or interesting, so I have a beautiful quote here. And this particularly struck me, and it's not because it was the first one that came up on the internet, which it was, but because it's really meaningful. Emotions can get in the way, or you can get in the way. And this is by a behavioral performance scientist, Mavis Missouri from South Africa. And it really reflects the complicated nature of emotion. Emotion has conflicting points of view, it has conflicting expressions, and it is just not an easy thing to study. So first I'm going to talk a little bit about why I'm here. Go back, we're going to take a big step back into the theory of communication, then really discuss what are emotions and what are some of the philosophies and theories of emotion and how those interact with this whole notion of communicating an emotion, particularly in a performance. We'll talk a little bit about physiologic entrainment and synchrony, and then we'll have a little discussion about practical applications. So let's talk about the theory of communication. So one of, I don't want to talk about my background in a minute. Why am I here? I'm a performer. I have a bachelor's degree in both vocal performance and in oral rhetoric. And because I really wanted to make money, I went back to school to become a speech language pathologist. I studied at the University of Iowa and specialized in voice. And in my clinical training, although I was prepared for it, and although I knew that I was going to deal with people who had voice problems and it was emotional, what I was unprepared for was the degree to which this was pervasive. It's a pervasive connection. It got me thinking about this idea that people's voice and emotion and their identity are all wrapped up. And I have to say, I studied from the greats. But what I didn't know about, because I was naive, was what about emotion? What about personality? What about this? So I went back to school, and I studied psychology and individual differences at the University of Minnesota. And my area of specialty is affective neuroscience, cognitive neuroscience, and psychophysiology. So you're not going to get any pictures of the brain from me, not even the waveforms that I study, but I'm a psychophysiologist by training. And my area of research is in people with functional dysphonias, so a problem with the voice that seems to be a result of a psychosocial imbalance or an emotional imbalance. It's clear in this situation that emotions do affect the way we produce sound. And so this topic of voice and emotion and of voice and performance is really important to disambiguate the notion that when we convey an emotion in performance, it's not necessarily the emotion we're feeling at the present time, that we need to do something different when we're performing. So, I don't think that there's any proponents for the Stanislavski school of singing vocal pedagogy, where you're just going to feel that emotion you're expressing in a performance, because sometimes that interferes with the aesthetic of the medium in which we're performing. So we need to sort of step back and talk about the theory of communication. How are we going to, in a performance, communicate to somebody else what an emotion is? So in my oral rhetoric training, we studied the theory of communication that goes all the way back to like Aristotle and Socrates. But Shannon in 1949, in his mathematical theory of communication, came up with a really great model that I think is very helpful, and I use it all the time in my clinical training, to think about where emotions start from. So you start with a sound source or a source, an idea, that gets formulated into a message and transmitted. And in oral rhetoric, we talk about the speaker being the transmitter. And then that signal is sent through some sort of channel, or sometimes we call that a medium. And then that signal is received by a receiver. And in this theory, the receiver just does a reverse transmission of, they just decode the encoding. And I don't think that happens in emotional communication, and we'll talk about that in a minute. And that receiver then sends the message back up to the destination. So that is like classic communication theory. So when we're talking about, I apologize, all of my citations are on the bottom of this slide, which I see here, but you can't see here. So I am citing Shannon here. So in a situation where we're wanting to communicate an emotional signal, what's happening is we're having some process going on in the brain, and that message is being sent to our expressive systems. The voice, the face, our posture, our gesture. These are emotional expressive systems that we heard a lot about in the last talk. And that system is being sent through some sort of medium. If we're talking about the voice, it's generally, the best medium is air, because sound transmits through air better than anything else. Well, water, perform underwater and listen underwater. And then that signal is received by the peripheral systems of the person who's listening to us. And then that goes up back to the brain and gets processed. So that is how we are going to communicate emotions, kind of through this process. There is a noise source in this model. We don't talk a lot about this in terms of emotional communication, but that's a whole really interesting area of research. So the lion's share of research either covers this idea of the perception of emotion or the acoustic signals that emotions, vocal emotions are going through. And this is where I do my study. I look at how emotions in the brain gets translated into specific vocal behaviors. As I said before, we don't know much about this, the noise source in that. So that is the framework we're going to talk about. So let's talk a little bit about what emotions are. So if you look at the Encyclopedia Britannica, which I used because British person here in the audience. The definition of emotion is it's a complex experience of consciousness. It is the body sensations and behaviors that reflect the personal significance of something. So these are very colloquially understood concepts. And it's an event or a state of affairs. And in this colloquial definition, I want to highlight the fact that there's body sensations involved in emotion and that there are behaviors, because this is the way cognitive neuroscience thinks about the purpose of emotions. So emotions motivate behavior. So I'm just going to fly through some of the historical thoughts on this. According to Peter Lang, emotions are action dispositions that are encoded in memory. So emotions are things that we have encoded in our memory that move us to act. Emotions are response tendencies. So there's these tendencies in our body to respond to things, whereas mood sort of influences the way we think about things. Emotions influence the way we move and behave. And emotions affect locomotor behavior. And recently, we think about emotions as a predictive code of our state of being. And that it links our introspective life with past experience to facilitate some sort of action or response. Right, so how does this do that? Emotions link higher brain structures with lower brain structures and oftentimes perceive cognition as it happens in the limbic system. We heard a little bit and alluded to earlier, but we're no longer thinking about the limbic system as just a standalone system. Emotions happen throughout the brain, but there are strong connections to some of our midbrain structures, to extra motor and extrapyramidal tracts. And so let's talk a little bit about some models of emotions. So some people think about emotions in terms of like, how are we going to model this? And so I'll talk about the two-dimensional model, the approach avoidance model, and then the differential pathway model. All of these models are engaged in research on voice and emotion, and some in performance. So the two-dimensional model is basically emotions are on a model of valence, which is from pleasant to unpleasant, and arousal, high arousal versus low arousal. And this research is quite old, and it kind of comes from a semantic differential methodology across languages. So they take a number of languages, they have people sort of sort out emotions according to how close they are, and they've come up with this sort of two-dimensional model. Sometimes there's a third dimension of dominance, but this is pretty standard. And so this is what it would look like. So basically, you have from low arousal, high arousal, unpleasant to unpleasant. So anger would be an unpleasant high arousal emotion, whereas excitement would be a pleasant high arousal emotion. Again, depression, low arousal, negative, contentment in the low arousal, positive emotions. So that's kind of a model of the way we look at emotions coming from looking at language. The other is an approach avoidance model, and that is a model that moves away from punishment or threat. Whereas the first model was how we categorize emotion. This model is how are we generating it, and we're generating it in structures in the brain that are sensitive to threat and helping us move away from threat, or we're moving towards a goal. So we're talking about some threat sensitivities here and some reward sensitivities there. And this is done in the affective neuroscience methodologies, particularly in animals and humans. And so these two models don't really differ from each other because threats are considered sort of unpleasant and goals are considered pleasant. So you have this notion of a two dimension, but it looks slightly different. So basically you have your arousal on the Y and valence on the X. And what we see here is that anger would be a high arousal and aversive experience, and excitement, high arousal, appetitive. And then we have depression and contentment down here. And as you get to lower arousals, what you see is that emotions tend to look more neutral. As I've heard before, there's probably no such thing as a completely emotionless system. But and then there's this differential pathway model. The lion's share of research on voice and emotion falls on this pathway. And the idea is that emotions are neurologically specific and they differ from each other. And that there are some basic, distinct emotions out there. Sometimes they're called natural kinds of emotions. And this, again, is coming from affective neuroscience methodologies, mostly in animals. Just FYI, there's some philosophical views that sort of mirror this. So we have the biological categorical model where there's a stimuli and a specific reaction, and each emotion is hardwired. And this is put forth a lot by Panksepp, who's a big researcher in this area, Ekman from humans, animals, and that emotions are quite discrete. Then you have this sort of social constructivist model where you have a stimuli and then sort of a general body reaction. Emotions are conceptually learned from our bodies, and this is quite old. This was sort of even posited by William James, the father of psychology, back in his article called What is an Emotion? And then we have this sort of computational or cognitive appraisal model, where you have a stimuli, you have a general reaction, then there's some learning that happens, and then you have specific categorizations sort of in an iterative process. So emotions are sort of constructed based on a learning paradigm, and that was presented by Lisa Feldman Barrett in her book, How Emotions Are Made. And so what we have here is competing views along this sort of deterministic biological emotions are just biological, it's from the brain down to the body. And then this developed environmental model. So we have some discrete emotions, we have some learned emotions here, and then we have some constructed emotions here. So discrete emotions are just automatic, it's sort of straight from the brain down to the body, and then we have this sort of semi-automatic, not in firearms perspective, but in learned. And then we have this constructed emotion that's iterative, that kind of moves back and forth and constantly changes over time. And so very early emotion research in discrete emotions began essentially by assessing standard, typical, or stereotypical emotional expressions. And the idea here is they use actors to demonstrate these prototypical expressions of emotion in the face, in the voice, and they really sought to develop biological signatures of emotion so that we could study emotions. And there's various, successful in establishing that emotions can be recognized and that we can recognize stereotypical emotions. So this is where a lot of the literature on voice and emotion began, with trying to come up with like an acoustic signature of a discrete emotion. And the applications, and so these are some of the basic emotions put forth by Ekman. Contempt is a later emotion that happened a little later. And there's a lot of research in facial expression, vocal expression, looking at basic emotions. So here's your resting bitch face. What are we talking about? So this is a stereotypical facial expression that's used from Ekman's system. And they use these to test whether people recognize emotions and kind of test emotional experience by viewing this. There are oodles and oodles of databases for vocal, emotional, vocal databases. And the lion's share of them are using these between 6 and 8 basic emotions. They're using actors. Some are only female, some are only male, but most are a combination of both. But these two are actually starting to use more naturalistic conversations. This one is these are actors, but they're in an improv situation. So they're looking at emotions, not just in terms of basic emotions, but they're rating these emotions on a valence and arousal scale. So it's kind of combining some of these models. And this vocal burst competition set is interesting. These are naturalistic vocalizations, laughter, crying, and there are almost 17,000 samples from different people across multiple cultures. So the majority focused on this research is mostly on emotion recognition, but this is where we start when we talk about how do we communicate an emotion. How do we recognize that emotion? And it's usually forced choice response, and I'm not going to get into the methodological quagmire that is, but the specific biological signatures are really elusive when it comes to actually producing an emotion. However, there's a lot of success in developing these signatures based on this two-factor or approach avoidance model. So we can have some idea that this is an angry emotion because it's high arousal, and we get anger from other pieces of information. The application to basic emotions, this is kind of poorly translated in naturalistic environments. So if we're talking about psychotherapy, or we're talking about trying to work through an emotional process, we are more complicated than 7 basic emotions. So this is not terribly useful when it comes to actually using and employing emotions in naturalistic environments. And it, again, is not representative of the whole thing. Particularly the complications of emotion in artistic performances. We don't see an actor as being a good actor because they do anger really well. We see an actor doing really good acting because they do anger and contempt and sadness at the same time. So when we're performing more complicated emotions. When we're communicating that, we have to sort of move to other models. And I'm going to move to the other model, which is the theory of constructed emotions that was put forth by Lisa Feldman-Barrett. And it's basically based on neuroscience evidence that emotional experiences are very varied within an individual. So I experience anger in different ways and across individuals. So my experience of anger and expression of that is different than yours. The idea is emotions are not innate, biologically driven. They are complex. They involve multiple brain systems and body systems, so we do not have an anger pathway that humans use. We do in animals, by the way, that other pathway. There's evidence for that, but not necessarily always in humans. They don't have a specific biological signature. They are learned through experience. Emotions are a learned through experience phenomena. And based on context. Context is key when we're talking about emotions. It's huge. And we learn emotions in a very similar way to language. As a matter of fact, we learn emotions through language. So again, when we're talking about language, we're talking about a very complicated system. And our emotions are based on expectations and predictions about things. And we'll unpack that in a minute. So emotions allow us to understand the full complex of emotional experiences, from things like how do we regulate an emotion to how does certain personalities express some emotions versus other emotions, or how do some states elicit an emotion differently than other particular states do. It explains the success in psychotherapeutic processes. As a matter of fact, this particular constructed emotion theory is really one of the reasons why cognitive behavioral therapy is so effective, because we are reconstructing our emotional interpretations of things that are going on in our life. And it's really unique in that its brain-body relationship is bidirectional. So if we look at the other two models, one comes from the brain down to the body, the other comes from the body up to the brain. And this is saying, well, it's a two-way street. And this particular conceptualization is helpful when we're talking about communicating, because that's also a two-way street. So it's helpful to kind of encompass the complexity of that. So how are they made? So this is basically the theory of constructed emotion, that the brain is constantly monitoring the body, and it's monitoring homeostatic regulation. So it's monitoring the allostasis, and it's really focusing on this autonomic nervous system activation. So the body is constantly monitoring that, and changes that are made in homeostasis in our body require very immediate, quick responses. We do not tolerate changes in blood chemistry or blood acidity for very long before we have organ damage. We do not tolerate changes in body temperature for very long before we start engaging in some sort of detrimental aspects to our body. So we need to respond very quickly to changes in our autonomic nervous system. And so efficiency is required, and it's achieved by predictive assumptions that are based on experiences. So when we have autonomic nervous system changes, we develop a prediction of, I believe this is what's going on based on past experience, and these predictive codes allow us to access a response system appropriate to the situation. So in essence, changes in autonomic states are going to trigger a predictive code, and emotions are this predictive code. That is what emotions do. So we have these changes. There's a number of reasons why we have these changes in our emotion. Some are sort of direct changes, like I am in a hot room, but most of them are really more complicated than that. So these changes in our homeostatic state aren't always due to one factor. They're due to a lot of different factors. And so it's the context. I keep highlighting context in red because I think that's important to think about. Surrounding these homeostatic changes that determines the nature of the prediction and thus the experience. That's really helpful in understanding what emotions are and what they do, because when we want to communicate that, we want to communicate this context and experience. So the brain uses interoceptive information. When I'm having an emotional experience, the brain is looking at interoceptive experience. So all of that interoception, which are our sensory, and other senses, by the way, not just interoception, but the other senses are coming from our external situations. So physical, historical, contextual context, it's using some external information, and cognitive concepts. So, for example, we learn emotions through culture and language. We learn what anger is because our parents or our caregivers told us when you're stomping around because you didn't get your way and your body is feeling a different way. They say, you must be mad. And so we are constantly being taught emotions by putting labels on them. And over thousands of iterations, we start developing emotional contexts that this particular sense is only this in one situation, but not another. So we have our interoceptive signals. These are from the heart, intestines, skin, bone, all of this interoceptive signals. And then we have external contexts, which are either our physical environment, our social environment, so the desire for company, need for communication, and then our historical experience, so basically our experience in the past, and our learned concepts, and that map is too busy to put on here, so I didn't put it on there, but just trust me, it's learned concepts. And so basically, we are taking information from all three systems, and we're integrating those, and instead of having a biological signature, we start sort of zooming in on like patterns, and we send that information to the brain. This is the only picture of the brain in the talk, by the way. And that brain constructs an emotion. So let's do an example here. So we have some interoceptive signals. Our heart is racing. Our breath is shallow, our stomach kind of feels like it's in knots or tight, and we have goosebumps on our skin. Our external context is I'm standing off stage, and off stage is really cold all the time, right? I'm in evening wear, dressed up, and so my external concept is, oh, I'm about to perform, I'm going to do a performance. All of that gets sent to the brain, and it says, I'm excited. You can be a different person, like me, and your constructive emotion can be, I'm petrified. Right? So you can have a similar experience to somebody else, and your emotion from that experience will be different. It's this emotion that triggers that predictive response. When I am excited, I am going to behave and respond differently to manage this soup of information than I am if I'm feeling a different emotion. Another example would be I have all of the same interoceptive signals going on in my body. And the external context is I'm on a train. I used to work in Chicago, so I'd hang out on the train platform waiting for my commuter train to come. It's December, and it's after happy hour where we always have beer and nachos, right? And so this is the external concept, but my learned concept is, I should not have beer and hot peppers. And all of that put together, it says, like, I am regretful. Like, this is not going to go well for me at 2 in the morning. So these are constructed emotions. This emotion is kind of preparing me to manage my interoceptive and homeostatic skills. So let's just briefly touch on interoception. For those of you who are a little fuzzy about interoception, it's our primary source of internal data of our bodies. It's the perception of our body's physiologic state. So interoception is how we perceive our autonomic nervous system functions. So we have brain areas to perceive our somatic sensory functions in the sensory strip. We have our occipital lobe that sort of manages visual, Heschel's gyrus is our auditory. Our interoception is actually processed in our insula, so it's processed in a specific brain area just to kind of process these signals. Interoception is system specific, so my interoception for, let's say, respiration is different than my interoception for my cardiac system. So all of these systems, we're going to have different and varying levels of abilities. So it's often measured as awareness, and awareness is really the concept of the combination of how accurate our perception is. It's like if my heart is beating at 40 beats per minute, which would be amazing, or not so amazing depending on where you started, and I'm counting my heartbeats and I'm at 40, I'm really accurate. And then my beliefs about how well I'm detecting that. So if I don't believe that, I think I did 40, but I'm probably way off. That combination is how we measure interoception. So it's really objective and self-report. We cannot really truly measure interoception without having objective and self-report models together. And they probably need to be system-specific about that. And so our internal experience is really important in emotional events. So when we're studying emotion and we're thinking about conveying emotion or even communicating that in a performance, we need to take internal experiences into account. Our external experience, our context, integration of a lot of sensory experiences and situations and memory. And so basically it's highly individualistic. We have a lot of individual differences in this area. Our history is different, but our ability to detect sensations in our environment differs. Our ability to integrate our sensations is different. Our past experiences, our current demands, what are we currently expected to do and behave in this environment? And so when we're communicating emotions in a performance, we need to have context as well. We need to communicate that. So here's our little communication, and Shannon's citation is right down there. So we have this cognitive emotional experience, and this is the message. We have to include shared sensory experiences and context. So when we're communicating an emotion in a performance, we need to communicate the question. So I'm going to talk a little bit about entrainment and synchrony, because I think that's going to be helpful in knowing how we do a communication of an emotion that's not necessarily the one we're feeling, but the one we want to communicate. So I want to talk a little bit about the definition of entrainment. So for the engineers out there, this is not sort of the airflow entrainment that you have in sort of like hydraulic kind of studies. Entrainment, I'm specifically calling physiologic entrainment, and not necessarily the entraining of one oscillating system and another oscillating system, and they put them together and they match in period. So biological systems sort of synchronize. So oftentimes the term we use entrainment, and the literature talks about entrainment, but what we're really talking about is synchrony, because entrainment is just two systems syncing up. Synchrony is multiple systems, not just syncing up in terms, you can be off phase, you could not necessarily be connected to one-to-one ratio with a period, you might be connected rhythmically, but not necessarily very specifically. So just take that in mind. We're talking about physiologic synchrony, like how do we synchronize? We do that within ourselves. Our body systems synchronize to ourselves, and there are certain behaviors that help that. So essentially, our respiration rate synchronizes with our brain oscillations in some situations. And our respiration rate synchronizes with our cardiac rhythms. So that is what's, and so we're not breathing at 60 to 80 breaths per minute, but our breath rate is dictating our cardiac rate and our cardiac variability. But it's also dictating our neural oscillations as well. And we can entrain outside of ourselves. So we can entrain to somebody else. We can also entrain to something not human. So our brain waves will synchronize to auditory beats and rhythms. And so that's something I think would be really important to think about when we're talking about entrainment. There's a lot of modalities in entrainment. In my studies of emotion in my PhD program, and when we started talking about emotional states, we talked about circadian rhythms. That's the very first system we talked about. There's a lot of literature on how our circadian rhythms sort of are the basic producer of a lot of our other biological rhythms. Our endocrine system is entrained. Sometimes the where we eat and when we eat will entrain to our circadian rhythms. We have a lot of research on our neural entrainment, and I think this is important. Neural entrainment, we entrain our brain to auditory signals. Entrainment in our brain to auditory signals is a really strong marker of social integration and social connectedness. So the degree to which people entrain to each other is a great measure of the degree to which we're feeling socially engaged with somebody else. We have respiratory entrainment. The one that we know a lot about is the respiratory sinus arrhythmia, where our respiration entrains to our cardiac rhythms. But interestingly enough, we can entrain our neural oscillations, and we can entrain to somebody else. When I'm speaking, you're entraining to my breath pattern. When I'm breathing through the nose, it's entraining to the neural oscillations in my amygdala and hippocampus, facilitating memory. Our cardiac entrains, I did talk a little bit about that. Movement, when I move, we can entrain to physical movements. And there's a lot of literature on speech entrainment. So for example, our phonetic space will be entrained as we talk. My phonetic productions will mirror your productions. That's called the phonetic convergence theory. We have a lot of suggestion that as we entrain to our speech and language, it's not just our physiologic rhythms, but it's our syntax, it's our semantics, it's sometimes even our context. And then there's a lot of information on entraining and performance. Interestingly enough, a lot of this literature talks about how audience members entrain to each other. And the big question is how do we entrain to the audience? And in theater performances, There's more evidence that audience members entrain to each other. In musical performances, we have music that has rhythm, that has complicated structures, that audience members can entrain to music that are so. We get entrained by listening, by watching, by communicating, by moving around, through cooperative activities. Actually, entrainment also predicts how fluid your cooperation is. And we entrain to social media. One of the interesting studies I had cited earlier talked about when we interact with social media, we entrain physiologically to the person that we're talking to once. And then as we continue in social media, we stop entraining to somebody else and we start entraining to ourselves. So the more you're on Facebook, the more you're entraining to yourself, not necessarily to somebody else, which I think is a fascinating thing. Anyway, entrainment explains embodied qualities like empathy, the benefits we get through rituals, cooperation, social bonding, and emotional synchrony. And entrainment is helpful in synchronizing our shared experiences when we watch a movie, shared physiology, and so on. So the question is how do we do that? We do it through entrainment. So when I am a performer, my job is to help you entrain. So the practical applications here are like how as me as a performer are helping you understand what the emotional experience is. And we have a lot of stuff done for us. The ritual of a performance, we're already entraining to that context. Composers and directors kind of give us that context. What's out of our control are distractions in the audience. Evidence to suggest that one person needs to be on their phone in the audience and you stop entraining emotionally. So don't look at your phone when you're in a concert. Environmental conditions, our signal clarity, audience characteristics, we don't have control over those things. So the question is, can we become entrainers? And how so? Individuals can facilitate entrainment, and some of the underlying qualities are the individual themselves has to be in a rhythm. You have to know what your entrainment rhythm is. Another one is you have to be clear about the signal you're sending. And then the third one is a quality that is hard for some people to develop, but we need to sort of read the audience. We need to entrain to the audience. And anybody who's a performer can kind of know what that is. And the last is entrainment, to entrain to someone, to train on someone else. It's not a pushy thing, it's more you're pulling them along with you. It's more subtle than that. So are there specific entrainment techniques for vocal performance? That's a really good question. I don't know. So there's other aspects to this research for communication and leadership training, communication disorders, communication differences, particularly in the neurodiverse population, that individuals sometimes struggle with the concepts of empathy and shared experiences. But the big question is can we teach someone to be a vocal entrainer or entrainership? That's my made-up word for this. And I have a little challenge for you all to think about what it is that we do and how we can entrain to others. I did this. I wrote it down, like all the things that I think I do when I'm training someone to perform. What are those signals that I'm having people send? Then write those down and then go to ChatGPT and just type in the question, how do you teach someone to be a vocal entrainer? And see what you get. Because it's really fascinating and quite hilarious because I did that and it was pretty funny. I'm not sharing it with you because I'm not too much, I'm a minute over. So anyway, I want to acknowledge my lab who puts up with my crazy ideas about things. But I really want to especially acknowledge my colleague Eugene Buter, whose research is mostly on didactic synchrony. And we have funding for PhD students and postdoc. And we have an MA PhD program for people who haven't gotten their MA in speech pathology. So come talk to me. We have great laboratory experience. My references. Thank you very much.